You.
Okay. And I just shared a document in the chat. So my name is Paige Prescott, and I have an education nonprofit called Computer Science Alliance, and have been working with educators around New Mexico and beyond to do more with computer science education. I was a middle and high school science teacher and was a MESA sponsor in a couple different schools. So I love MESA. I love what you guys do. And then I love the fact that now the worlds have collided in the fact that these projects are now emphasizing computer science. And because computer science is likely not what you're teaching, it is, I wanted to share some resources to get you started, to kind of spark some potential ways to engage with your students. I know that you're coming from a variety of schools. Some of you might have colleagues that are doing computer science as classes, electives, or clubs, or things like that. And maybe some of you have experience with computer science, and I'm trying to hit a broad range here. So the first thing that I wanted to talk about is that, so we're going to end up with lots of tabs open, just as an FYI. And the computer science is becoming, such a pervasive area. And, if you ever need some ways to communicate about the importance of computer science, there is this page, and it's this one called code.org promote. And they have all this amazing data that they have put together about the different importance of computer science in education. And you can even scroll down to your own state and click on it and get some information. So I'm based in New Mexico. I can click on that, and we can get some pretty quick data, on how many jobs are open, what are some of the facts about it, some policy, and then more information there. So you can look at 40,000 jobs in computing in California. I mean, these are scale numbers that are really impressive. And so it's really important, the work that you're doing with your MESA students, to really get them excited about computer science. So I just wanted to put that in there. And then there's other resources that are here. I did link in this document. There are so many good videos around computer science. And so that's up here at general resources. Just really awesome videos that are well put together, that will explain different aspects of computer science, or just be motivational in general. So if you click on that document, you have these short videos on a variety of topics. I like the one here, what makes a computer, and it talks about the 4 components that all computers have, and it kind of gives some foundational knowledge before kids even get into the coding. But then you have other things about different content areas. And again, I just like these resources to inspire and inform. So that is up here. And then one of the things that's happening next week, starting on Monday, is the annual Computer Science Education Week, aka Hour of Code. And if you haven't looked at it, this resource here has all these different activities. And so they're meant to be 60 minutes, 1 hour. And you'll notice that these are curated in terms of grade levels, but then you can also do beginner and comfortable. And then you can also sort by who created them. So there's, vast lists of people, organizations that have contributed to this, and also what the technology is, what the different topics, etc. And so this is a great way to, in your short MESA meetings, to have some filler activities. Even though next week is branded as Computer Science Education Week and Hour of Code, these resources are available all year round. And they are discrete little lessons. So they're not curriculum or anything like that. And so this might be a way for you to build skills in a soft, engaging way with students. And there's all sorts of different languages that are using, computer language that is, and then also probably some translations for spoken languages that your students might have a dominant language other than English. So going back here to this shared Google Doc, I want to also talk about, there's a bit of like an industry preference, of course, for certain computer languages. However, these are K-12 kids, they are learning. There are, like, your students have maybe all sorts of different backgrounds. And in this shared Google folder, I put a research paper, and it's about, oops, let's let it open. There it is. So this is a large scale piece of information, and I just want to emphasize that block-based coding is as valid, if not even better, than text-based coding for engaging our students that are learners to computer science. There's a lot of data out there that says that block-based coding is better for learning the fundamentals. And in fact, if you look at this abstract, it says that basically the block-based coding gets to the same content knowledge, and we're talking about an N of 5,000 plus students, and that they're also that female students and students from historically underrepresented minorities saw the largest improvement. So that means that block-based coding languages as introductory computer science is really important for getting kids engaged in these topics. So I advocate that block-based coding is a great way to start, and not just start, but to continue learning these foundational concepts. So I just want to put that out there. If you have any comments or questions about that, I'd be happy to talk more about it, but I really just wanted to share resources. And that's one of the seminal papers that shows that you might have volunteers that come into your club and are talking to kids, and they might poo-poo block-based language, but in fact, the research says that pedagogically, it is a much better way for students to engage. So there we go. Thanks, Anita. Appreciate, yeah. They are, block-based coding language came out of Scratch. They pioneered it in 2005. And deployed it widely, I think, in 2007. So that's why we're starting to see, like, we didn't grow up, many of us did not grow up learning block-based coding language because it didn't exist. And now it exists, and it's a great pedagogical tool. And so going into that, so the way that I organize these all sorts of resources is to what kind of level they address, in my opinion, a short description, and then the link. So web development is a great way to get started. In fact, I was listening to a talk recently about how MySpace was one of the places that lots of people got involved in computer science because they were using HTML to modify their MySpace pages and customize them, and they were learning code in a way that was very creative and authentic. I'd like to point out that this resource called Glitch, and so everything that I'm pointing to is free, and that they should be, all students in all devices should be able to get to them. Of course, you do need internet access for the majority of these. But Glitch is a great resource, and it's one of those freemiums, so it starts off free, but if you pay for more, you have a little bit more capability. What I like about Glitch is, for HTML, is that you can, it's like a Google Doc. You can have teams simultaneously edit the HTML so that there is a dynamic way of engaging with teams on this. And then you could also be included in that to see what they're working on. But this is all sorts of resources around web development and learning the different interactions that can happen with that. So highly recommend this. And they do have different in order to have a team, you have to, you do have to have a login. So the kids will need to create a login and then link it, but, and know each other's logins, in order to share a, co-editable, web page. Another way to engage with web development is like, so maybe you're not an expert, but you want kids to kind of increase their learning, in a way that gets them to a certain level of understanding to develop their own. And in which case, I would recommend thinking about the CS Discoveries curriculum, which is out of code.org, and they have a whole web developments unit. And it just kind of goes through a little bit of like a sequence. So then it takes the onus off of you as an educator to be the deliverer of information. And so this is a little bit more autonomous learning that students could do. Of course, this is curriculum, so you maybe have a colleague that is doing CS Discoveries as a in their class. And so you'd want to check in with them. But there's some nice onboarding of some basic pieces here around HTML. However, this is not as easy to share across multiple students. So that's why I wanted to introduce you to Glitch or anything like that. If you have any questions, you're welcome to unmute or to put something in the chat, but I'm just gonna do a brain dump with you all and then see what is working for you all. So I just did the Glitch and the, what is this called? The code.org. And then again, at the beginner level are so Microsoft's platform is called Make Code, and it is for the coding environments of Minecraft, microbits, circuit playgrounds, and arcade. And so there's all sorts of things that that they've put together or that they're giving out to us as educators. And so there's some resources here that you might want to explore in terms of either gaming or the different editors that they have, including Lego and some of the other robots that they have, that they're like supporting these devices that are out in education and saying Make Code is your sort of platform for what is that called? The coding environment. And then going back, we have building on microbits is this. So microbit.org it started out of the UK, and so it's an international organization. And I wanted to point this one out because I think it has particular relevance to you all and your upcoming challenge for the students, because what they did is they used to have a Do Your Bit challenge that was international, and that was because it was international, they linked it specifically to the UN Global Goals. And so there are resources here that are linked to some of the different goals. So it goes over what the global goals are. And it has some very specific resources, including, what is that called? PowerPoints or presentations, I should say, that you all could use. I'm navigating they've changed some of the placement of these, but the Do Your Bit projects are Do Your Bit Challenge Pack. Let's try that. There we go. So the one that I'm familiar with, so it's not every single one of the global goals, but these are the ones that they have resources aligned to the different goals. And the one on life on land, if you can go and download it, but there are activities about what it is and why it's important. And then there are some sparks of ideas around the different projects. And one of them, the one that I remember, and you probably have to download the guide here, is that it was based on tree cutting. And so they had microbits that were utilizing code to be sensitive to, like poaching of rare species. And it's worth exploring because there are some really great resources, including the prototype of what that code could look like. So that one, I think, has a lot of relevance for you all. Now, going back to just kind of general resources, this one, code.org has put together what are called CS connections, and they are looking at different connections across content areas. And this is, I would mainly consider this a way of engaging students to think about a topic, as opposed to, this isn't going to be their project, but it's kind of engaging them as a group to think about what they could do, specifically these two around marine species and ecosystems, and then the mapping. And then also another thing for Scratch, like Scratch is sort of the foundational resource that pretty much every student and teacher should know about and should explore. Scratch, like I said, is the group out of MIT that pioneered the block-based coding that now is ubiquitous across many different coding platforms. And so, and it's not, there's not necessarily a curriculum around Scratch, but there are all these great tutorials that could engage students in thinking about just learning the basics of this interface and the coding environment. And then I want to point out that on Scratch down here are these extensions. And so you can use Scratch to code a microbit. You can use Scratch to code different robots and things like that, and also to be collecting data around these force and acceleration. So there's a little bit more that might not be obvious unless you go back to those, unless you are aware of these extensions here. So, I mean, the power of Scratch is really more about the, well, it's creative first, and it's animation based and game based. So there's not a way to get a lot of data out of a Scratch project unless you are looking at some of these extensions. Let's see. So then going back to Scratch, or yes, question?
I'm so sorry. Can you, I'm looking at that page, but I'm not seeing exactly where you were. Could you just drop your link from that, from where you were on the, yeah, I see that, but then I wasn't seeing you when you scrolled down. I'm on that same page and I'm not sure about the extensions.
Yeah, I'm trying to find the extensions too.
Yeah, you know what? It's kind of off of my, so so down on the, we're in Scratch, and on the under the code tab, all the way down to the very far left is this purple plus.
Okay.
Yeah, sorry,
Thank you.
that isn't obvious. I agree. So here's that purple plus, that little extensions, and then that's when you click on that, that's when you get this.
Huge. Thank you so much.
Yeah, sorry. Thank you. I appreciate you asking that question because I'm sure others had the same thing. All right. And then I do want to point out that Scratch is both web-based and it's downloaded. And so if internet is an issue, but you still want kids to be doing stuff off, like in a way that is on a computer, but not with internet, you can do that with Scratch as a downloaded format. And then if they log in to both them, it will sync once internet is available. And then I have a few resources around app making. So this would be apps for phones. App Inventor is kind of one of the pioneers of this, again, an MIT free product. This is really good for Android phones, although they do have a way of the iOS on an iPhone working. It was made for Android phones. And so if you're going to test it, it is better to have some old Android devices available, or it doesn't have to be old, it could be regular. But there are great little tutorials around how to do apps, because I think that it could be a great way of collecting data that students are thinking about, or sharing information, or just kinds of depending on where the project is headed. But this has some really good tutorials again. And then although they say it's for beginners, I think this is more of a mature beginner, someone that has a little bit more persistence and perseverance to get through it, because it can be, the interface, the way that it works can be a little bit challenging to kind of port over once you've done it on the App Inventor site, to port it over to a phone itself. I mean, you don't have to have it ported over to a phone, but that's kind of the sweet spot, is like kids seeing it working on their own device. Again, for apps is the app lab that code.org has. And this is a whole sequence of activities around app development that can really get kids kind of oriented to what apps can do, and then how to code them and things like that. And this is using JavaScript as the coding language, but it goes through a sequence of activities. So again, the onus is not on you as the club leader or sponsor to know everything about how to get stuff to work, but this would be building skills within your students in order to create their own. And then all of the apps that are done in code.org's JavaScript have a link. So they are web-based. And so then you could send that link via text to somebody, and it would show up on the phone and be workable on the phone, as long as it's connected to data and so on. But
Hey, can I ask you a clarifying question?
Yeah.
So I asked in the chat, but I know it's hard to see the chat when you're.
Oh, I just noticed. Yeah.
Oh, no, that's okay. So MIT App Inventor and App Inventor 2, is there a distinct difference between them? Because I feel like App Inventor 2 can publish to both Android and Apple, but I would love clarification.
Yeah, so I haven't been as familiar with like their updates recently, but yes, the App Inventor 2, I would always go for the one that has a number on it. Like, you go for the higher number, because that means that they've released something, but that maybe they're supporting the old way to do it, the old interfaces and old connections, because, as educators, we're not always going to have the most recent tablets or Android phones to like test it. So go for number 2. And then, yes, they have been, they talk about their iOS interface. It does work, but it is also, from my understanding, glitchy. So if iPhones are the only things that the kids have available, it'll work, but just, it can be a little challenging. So that's that persistence part and problem solving part that we want to encourage students to have. Yeah, so it's not a definitive answer based on personal experience, just my general knowledge. Let's see. Then we have, so that's apps and some general things. And now Arduino is, well, before we get into Arduino, there's Tinkercad. So Tinkercad is from Autodesk, and it started mainly with 3D. There you go. They can use emulators. That's true. The Autodesk is like, all the CAD stuff. And so they created this for 3D printers, but they've gone beyond just that. And there's all these resources that will get students to think about circuitry and electronics. And so they would have to understand some of the flow of electricity and how that works. And so there's some nice tutorials and interactive experiences there. And then there is coding that can happen that communicates with the 3D printer, or it can also help develop things that are microbit related or Arduino related. So this gets into physical computing. It kind of bridges between 3D printing to physical computing in an interesting way that is quite engaging and has lots and lots of resources here. So, you know, you can always sign up as a teacher and create classrooms and things like that. But all of this is also like, you don't always have to have a login to get started. And so building on that is the Arduino. So finally, Arduino has a decent web-based interface. That wasn't true for a while. Or in sort of the educational experience. Arduino came out of the DIY, the do-it-yourself kind of movement that led to maker spaces. And they weren't truly in it, like they originally weren't targeting education, but then it clearly was a great educational tool. So there's some Learn Arduino tutorials here. And you can also install the desktop application, which is going to be, in my mind, a more authentic experience for your students. And they're going to have a little bit more control over that, because once it's downloaded, then you don't need the internet. You just need the device and the communication tools. You do need to be aware of like so many different boards that they have, and then the computers need drivers that communicate with those boards. So it does take time, and you might need to be connecting with your IT department to make sure that things are available and updatable so that all sorts of devices can work with this. But Arduino has sort of a huge, I'm sure most of you are aware of it because it's been an emphasis in MESA. But there's all sorts of resources here that can get you and your students involved in projects and different ideas and things like that. There are these documents and setting it up and all these different ways to look at these things. However, it can be a little overwhelming because there's so many choices that are out there in how the different Arduinos are interacting with your computer and where the coding is happening. But a fantastic microcontroller, sort of sky's the limit in what's its capabilities. And then similar to Arduino is the Raspberry Pi. So a Raspberry Pi technically is a true computer because it has an operating system, and that's different than the Arduinos, which are microcontrollers. Same thing with microbits and Circuit Playground Express. But Raspberry Pis have a lot of capability for Internet of Things kinds of projects. And so little Raspberry Pi, and then there's these, it can interact and with an Arduino. It comes loaded with Scratch, Minecraft, and Python. And then its operating system, which is open source. And there's all sorts of, with Raspberry Pi, they are education based and really trying to think about like the experience here for students. So you can code a Raspberry Pi with Scratch, but you can also get into, this is the physical computing, the Internet of Things that I was talking about. So there's lots of ways to get that to communicate in an interesting way. But it can be challenging to get success out of these projects. They're a little bit more advanced, which is why I always recommend microbits as a place to start with that learning experience. But Raspberry Pis have so much other stuff that they can do. And in fact, they've added Unity, which is a 3D kind of virtual reality AR environment, and then the Python and the microbit. So this is, and I'm not familiar with the web design, but I'm sure they have great resources on that as well. But lots of different tutorials that are available here. and lots of just ways to engage with this. And speaking like Python, so Python is possibly a way that a coding language that your students might be interested in, especially if it's data oriented. So Python is really good for big data sets. And so if they're moving towards something that's more like machine learning and data analysis, and then or towards AI, Python is a great place to engage students with. And Trinket is a good platform for learning Python, so some basics about it. And again, this is sort of a web-based interface, but Python is actually like as a language, like you have an IDE that can be downloaded and then you're coding directly on the computer in Python. But this is a web-based Python environment to get oriented to how Python can work. And so they do have a transition from blocks to code to text-based. And that's also true for microbits. Microbits can be programmed in blocks, JavaScript, or Python. And so there's just some nice ways to engage with that. And I just like the different tutorials that Trinket has around Python and to engage them. A lot of it starts with what's called turtle code. So they're looking at the visual stuff, but then it can get into more of that data work. And then I personally would like to encourage NetLogo, and many of you might not have heard of NetLogo. NetLogo is a coding environment that is what's called agent-based modeling. So everything that I've been talking about, HTML is its own coding language for websites. It technically is not a computer science language because it doesn't have the logic that true computer programming languages have. But it's a good gateway and certainly viable as a coding, engaging in coding. And then things like Python and Java and C++, like all the robotic languages and things like that. Those are object-oriented programming languages. And then there's NetLogo and sort of the Logo suite of languages, and they are agent-based models. And what I like about this is that you can prototype some really interesting, students can do what are called computational models and do some things that would be quite interesting. So I'm going to switch screens and show you what NetLogo looks like. So NetLogo does have a web version, but it also is, it's better as a downloaded one. So it could be, once it's downloaded, be done offline. And so this is what its interface looks like. It's very retro. It's very old school, but it has some really good capabilities. So I don't think I'm going to go to my files, and there's what's called a models library. I don't think you can see that. But there's a whole suite of models that come downloaded with it. And it's a very small file. It's not a huge file that you need. Actually, let's see if I can, there it is. Okay. So this is what the models library looks like. And so there's different biology, chemistry, physics kinds of ones that are in there. And then things that are curriculum related. But I like this because like you can, in social science, like what if your kids are attracted to like understanding something about like the social science of something like epidemics or something, or share, or like gossip, like how does gossip spread? I don't know how that would relate to the UN global goals, but I'm sure there's something. And they can kind of look and see how different, like here's that rumor mill, and how does information spread? So let me change the screens now. And so this is what it looks like, the interface. So you have the setup, you have the the go and things move. There's data that can be collected. And in this case, this is what the code looks like. So it's text-based, and they can, it's a very user-friendly text language that does something quite different than any of the other things that I've been talking about, because it's agent-based modeling. And so like epidemics, so if it's the spread of a disease, it's very similar code to the spread of gossip. But then you are able to make some really quick modifications that will lead to a lot of great data, a lot of great discovery, a lot of variables that students can introduce and understand and communicate to for their projects. So this might be unless you're from New Mexico, where we talk about NetLogo a lot, this might be a very new interface or a new coding approach for you that I highly recommend. There, like I said, they're in the models library. There are a lot of things that students can look at. For instance, actually, let me open up the one. It is fire. Where is that one? Of course, it's going to take me too long to find it, but oh yeah. So this one is about fire, and so the variable here is density. You can set it up and set it up differently. So those would be representing trees. And so let's go here, set up, and then you hit go, and it's doing burning. So like the density is, at least in this model, they're showing that density has some impact on the spread of the fires. And so students could play around with this and modify it in a way that they could create their own learning. So I'll stop waxing poetically about NetLogo, but I do recommend it as a place for students to think about sort of large scale, what's called complex systems models, that have a lot of capability to conceptually show information that's of a scientific nature. And then the last couple ones that I wanted to do. So GitHub is an important place in the professional field, and it's often introduced at the college level. GitHub is a place where if they're using a text-based language like Python or Java or C++, they could get in and have accounts, and then teams asynchronously could be working on their code, upload it into the GitHub area, and then it could effectively bring those projects together, like the code together. So you'd have multiple students kind of working on versions of the same project, and then it's a version control platform that is used in professional fields with teams of coders, and then they're working on complex projects and bringing it together in a way that they can, if it breaks, they can always go back to a prior version. So if you are working with high school students that are ready for pre-college experiences, I recommend that they explore GitHub. There are some education resources around GitHub for the K-12, but mainly it is a higher ed, like a college and professional level tool, but great to expose your kids to. And, oh, there we go. Thank you for posting that. And then there's a couple things that I just want to point out, that the work that you all are doing is pointing kids to be successful in an advanced placement class called Computer Science Principles. And so even if your schools don't have AP Computer Science Principles, it's at least knowing that even at the middle school level, you're really creating them to have success for a high school level course that is aligned to College Board standards. So, you might want to be aware of the fact that your work is preparing your students for sophisticated advanced placement courses. So I talked really fast and I'm done a little early. So let's have a chat and ask questions. And then are there things that I didn't put on here that you were curious about?